Oh, yeah, that's a good
So
idea.
yes.
So basically, I've used cloudering on a number of projects, especially the ones you can build on Heroku, because we need a very fast CDN, and cloudering is just so easy to use, and it has all the abilities to crop images. It can offload that work, which is, let's say if you have to build it in an app and you're starting from scratch and you got to build the whole crop, resize, transform photos, it takes you about a month of not sleeping to build it. And cloudering has it as a service, and it's great. And also it's on top of S3, so you have good latency anywhere you want to launch your website. All right, enough for the commercials.
You can start with the kernel.
Slide deck. You can use this. Sure. Great. Let's go back.
All right, so serverless data pipelines. It's basically how to build data pipelines without a single server running 24/7. I'm Ivan. Last name is pretty hard to pronounce. Don't worry about it. I founded Divinity, which is a software engineering company. We build tech products for startups. We were a couple of tech guys 10 years ago. We formed a community about 5-ish years ago, and then recently we became a full-fledged company. How it all got to be, we started to build our own products, and while pitching those products, the investor said our business was not that good, but we were good at building. And he asked us if we want to build the tech product for one of his other investments, which the guys weren't that good at tech. So that's how the ball got rolling. And now we got a number of clients who are building their tech products. I can't really talk about it because I'm under strict NDAs, but I can roughly say some stuff. So if you guys want to ask about that, sure. Okay, that about sums up the next slide. All the cliche stuff. Wrote it first spell before it could read. 10 years getting paid to build stuff. Serial entrepreneurial failure, 10 times and counting, which means I don't have anything that's worth $1 billion. And if you're not going for $1 billion, why the hell are you working on startup? So, see photos for a lot of very dumb stuff I do. As I said, when we started as a community, pull our own products, stealth mode, no NDAs, no photos. Sorry, too many NDAs, no photos. So what's it about? Basically, a love story in serverless data pipelines and startups. Why? In startups, you kind of don't have a deployment team. You kind of don't have an architect. You kind of don't have a lot of people, which you do have in big companies. So you got to have one guy that's doing everything, right? And sometimes it's hard for that guy to keep the documentation, to keep the deployment procedures, to scale servers. Imagine you have 5 servers, and then you need 10, then that guy has to go put it into load balancers, write a bunch of bash scripts, and that kind of stuff, right? Well, if you use serverless, you can basically have it all in one nice little project, which has everything in it. The deployment, it can scale, and everything else. So one guy can handle it and still be SSD, which is good if he wants to. So serverless. There's a big commotion about is it an architecture? Is it a framework? It's both. So it's basically means no servers allowed. So everything is running as Lambdas, preferably on AWS. I've used some other providers, but honestly, AWS just scales and works and delivers what it's promised. Data pipelines. So everybody needs data, right? All those ancient features that we want, that we see on websites, we see them as just one little button, and there's probably petabytes of data behind it being processed all the time in real time and reacting to changes to give us just that little one button click. Startups, 21st century version of inventors. They shake the world, they disrupt industries, they build and go up against big tech companies, and the only difference between a startup and a big tech company is startup has to do stuff in a smarter and faster way, and a lot more passion. So that's how you do it. All right, let's get something. Data pipelines. This is a definition from Wikipedia, which kind of negates itself. So data pipeline, also known as a set of data processing elements connected in series, where the output of one element is the input of the next one. Then it says it can often be executed in parallel. Short version, bunch of code that gets the data from one source, processes it, normalizes, transforms, do all sorts of nice things that our product owners have ideas about what they should do with the data, and then stores it so that it can get fast for the APIs and eventually the customers to access users. So hopefully it does all of that really. Data pipeline metrics. What are the two most important things when you build a data pipeline? It's the time when something changes in the data you are retrieving till the time where the client sees that change. That metric is basically called a time to live. There are other definitions, time to sight, but I think the most accurate one is time to live because it will be live once the user sees it. So, and it kind of describes itself. Another thing is you need to make it cost effective and it scales. So the second most important feature is scale. Part of scaling is also being cost effective because if you have something that can handle an insane amount of data but still costs the same amount of money when it handles low volume of data, that's not really good. It's not really scaling. It may be scaling for the users, but it's not scaling for the company, so you're gonna run out of money. Next thing, make sure it doesn't leak too much. I'm saying that again because every data pipeline that I've ever built loses data. Whether something changes on the data provider side, or some framework changed, or some library that parses the JSON doesn't work well with another library that parses the JSON. So things can leak. It would also be nice if you don't spend a lot of time checking leaks, and by leaks I mean a lot. In data pipelines, you're going to have a lot of pieces. Getting the data, normalizing the data, integrating external metadata, and there's a lot of places it can go wrong, so make sure you build it as resilient as possible. Serverless, like I said, is it a bird? Is it a plane? So is it an architecture? Is it a framework? It's both. It's basically an architecture supported by it. So the architecture means software design pattern where applications are hosted by a third-party service, eliminating the need for server software and hardware to be managed by a developer. Very important part, eliminating the need for the developer to manage the software. As a developer, you only want to be focused on the piece of code that you build. Anything else is just a waste of time and energy and just a burden. You don't want to be woken up at 3 a.m. in the morning because of the server crashed and then it was actually a load balancer, so everything crashed. The serverless framework, it's a free and open source web framework, probably most of you know about it, written in Node.js, originally developed only for AWS, now it supports other infrastructure as a service providers. So, serverless data pipelines. Basically, build a server using the serverless framework, following the serverless architecture design. Short story, marriage between serverless and data pipelines written down in the YAML config, because we all know that's where the infrastructure is stored if you're using serverless. It's also backed by CloudFormation, so if you build it once, you can replicate that in a completely new environment in a matter of minutes, which is amazing because at one point you're going to have to refactor the data pipeline. It's going to be good to have a playground without actually impacting the production services. All right, the desired goal. Everything, no servers, completely event-driven, streaming near real time without a single server running 24/7. As again, you only want to be focusing as a developer on the code you're writing. And if you build your pipeline like this, you're only going to be working your own code. Benefits. Remember time to live, the metric between when something changes and when a user sees it. That is cut down drastically by using the event-driven nature of serverless, because you're reacting on events. You don't have a process scheduled somewhere to run every 15 minutes, which means your fastest time to site, in theory, can be 15 minutes, because every 15 minutes you're checking. If something comes along every 15 minutes, it's going to wait 15 minutes. If you're event-driven, it's something, as soon as it comes by, you're going to react on it. You're going to get it to customers as soon as possible. So, scaling. It's also achieved by the same factor of serverless. You can build event-driven stuff, which means the more events, the more processes are going to ramp up, and you're going to scale with the data. It also means when nothing is happening, no CPU is used, you're not paying anything. So it's cost effective. It's scaling the money you spend on your infrastructure, to put it that way. All right, let's see an example of what's known as a serverfull data pipeline, which means all of your code is running on a server that's mainly running 24/7 because the code has to be somewhere. Even though if you have a cron job scheduled on it and your code runs every 15 minutes, the server has to be there 24/7 because the cron job has to run something. So, simple example. You're running an FTP server for your clients to drop off data, right? So there's one FTP server. And then on the next server, you have your extraction code, process, service, whatever you want to call it. It's basically a code that's scheduled to run every 15 minutes. So every 15 minutes, wakes up, picks up the data, puts data on S3. So the next process you have is basically processing, normalizing, transforming the data to your internal standard or to another standard your data should follow. Or if you have a schema, you gotta provide a SQL schema. All right, so after that, you got a process which is every 15 minutes that takes that data, normalizes it, puts it into an SQS, and then the last piece, which is the loader, which takes the normalized data, and its only job is to basically put it in the database. This is what you would call the service-oriented architecture, which means every service has a role to play. You should not put two roles in one service. So, service-oriented architecture backed by a serverfull infrastructure. All processes are scheduled. So, let's say for an example, can anybody guess what the quickest time to live would be? Like the smallest time to live would be for this data pipeline. Go.
Almost instantaneous.
No.
11 minutes.
Yeah, close to 15. Because you would run one, so you would run the extractor every 5 minutes, that's 5 minutes, and then the processing every 5 minutes, and then the loader every 5 minutes. So that's the lowest you would go. In case that the extractor takes a longer time to process stuff, then you would have to schedule the processing to be more than 5 minutes, so 15. So it can go from 15 minutes time to live to 45 plus easy, because everything is scheduled.
Good question. So when you say quickest, for example, in case that I upload my file exactly before the extraction is scheduled to happen,
Okay.
would that happen really quickly?
Yes, because you still have the other 10.
They can happen exactly.
Yeah.
What if I
So
schedule in a way that
they have to be, so the processing has to be done once the extraction is done. So it's sequential.
I think this point is that the extraction happens within a minute, and the next, next schedule happens right after that. And
Yes, but then the data there was, if let's say the processing is done faster than the extraction, which is usually is because this one acts as FTP. So this one is done within a minute. This one does its work for about 10 minutes, right? So this one is going to be done, and everything that was 9 minutes after the extraction will not get picked up until the next cycle. So I think that answers the question.
yeah.
All right, let's see the serverless version of this. So you can take an AWS managed FTP on AWS, which means you don't actually need a server. You just set up the FTP. What you're basically going to get is, as soon as somebody uploads your data to your FTP, it's going to end up in S3. Yeah, exactly. I forgot to update, sorry. I made this 3 days ago, so it's a bit old, sorry. Okay, so you get stuff on S3. As soon as the data lands in S3, you're going to get an event that's going to trigger the data processing line, which means you basically skip the step where you have one process that's just doing the extraction. If 15 to 15 minutes. So you have less code, and the time to site is going to be shorter. The data processing on the process it, does whatever it needs to do, publish it to queue. And then the loader takes it from the queue because recently, from July, I believe, SQS can trigger lambdas. Before that, it was only SNS, but now SQS can do that too, which is, in my opinion, amazing because SNS, you don't really know what's going on because you don't see the number of messages in the queue. This is really cool because you see 150,000 messages and they're going down. So you know how long it's going to take before it finishes all the data. And in case something goes wrong, you have the retry and the dead letter queue, which is also cool. So stuff ends up in the database. $100 question. What's the time to live metric for this one?
Basically, how it used to do virtual machine host this service application, right? Like the Serverfull or whatever, the same concept basically. Handle the security, just make sure that all the team can access the whole stuff, not all the cost.
So let me make sure I understood the question. How does AWS handle security for the process?
Well, service
Oh,
application.
because you're using AWS Lambdas. So AWS handles that.
They have an execution role.
Yeah. There's an execution over what it can access, what it cannot access, what it can do. There's also user rights. You can trigger their Lambda and other stuff. That's the biggest benefit. You don't have to worry about that. Okay, back.
Well, if it was a public entity, it was secure. If it was a public entity, it was secure.
Public endpoint for the FTP.
No, I mean, the difference, say, you use
API.
So
You can even have Cognito if you want with switching temporary
Say,
credentials.
if you were making like a contact,
Sorry, it's just me casting.
So say if you were making a contact form,
Okay.
and you use the Lambda function to process that, and then you put that endpoint as an action in your submit that, for instance.
Okay.
How would you secure that endpoint? Incognito would not work because you need users to sign in, so users to sign in your website.
How would you define security on
Secure in the sense that maybe cross-site request. If I take that endpoint, put it on a different website, I can run the Lambda services.
So within the Lambda, you can, if you want, put in Spring. I don't advise it with all the security.
It's actually API gateway. It's not something for secure.
Yeah.
Select that. In addition to that, also on the API keys. So you actually controls the way you want it. If you want to make it public facing, or we want to use specifically only access to certain people or certain API keys.
And on top of that, if you want, you can push Spring into the Lambda itself. Use Spring security to do whatever you want. Norris.
One of the bigger concerns there too is probably the opportunity for external services options. Say, for example, someone runs up your, I think that's probably one of the concerns. If you have a public facing endpoint, someone decides to silent or DDoS it, and we're not sure what's going on. That's if you don't have good best practices in the company.
Yep.
I just want to throw in that. So this architecture is, fundamentally looking back at the previous one. So there's a public FTP is the entry point, so that concern being publicly accessible is the same way. The rest of this, I believe, actually all the services will be supporting an internal private network, and nothing else will be connected to the private business. So you can have all of the APIs, like the Lambda functions, will be internally accessed, not publicly accessible. So it would just be the security of SMTP or FTPS, whatever that is. Which, go to S3 writing directly versus that anyways, but it's already.
I did have a question about why SQS just moved to this architecture, actually. Because from what I understand, in terms of what the benefits of serverless is the fact that each of your two values there are infinitely stable?
Up to 500 values per.
Okay, so if you're in a space
Incorrect.
exceeding the number, that would be an as well.
It's also throttling. It's basically throttling and fault tolerance. So let's say you don't have that method, right? You don't have anything in between, and then the data processing on it just goes directly to the database, even though it's against service-oriented architecture. But when you're in a rush, you would sometimes have to do stuff like that. So what would happen is the database, let's say you don't have enough capacity in your DynamoDB, or God forbid you have a SQL database in there, and then that would slow down a bit. Whereas here, it's kind of a buffer zone, gives you fault tolerance. Let's say something else is behind it. It's not a database. Let's say you're getting information about an external data, let's say for an image, perhaps, and that thing's going to be a lot slower than the processor. And then you have that ability to slow it down or speed it up. If it's a process that you don't really care about, it's not a critical data path, which we'll talk about later, you can have it running slow. Let's say I want maximum 10 lambdas at the time. I want this to ramp up a bit build. It's not really the most important data in the world. If it's a couple of hours late, it'll still be here. Yeah. No worries.
So what if my lambda triggers the other lambda, and then I have retries on the other lambdas, and like I'll make sure that it triggers the whole thing.
So it can retry only a given number of times, after which it's going to end up in what's called a dead letter queue, on top of which hopefully you have alerts so that you actually go in and see what's wrong. All right, back to the original question. What's the time to live metric for this one? In theory, instantaneous. The time it takes the lambdas to process the data. All right, this is basically one versus the other. I think we're going through all of this. We go to questions, which is awesome, which means you completely get what I'm talking about. So, reactive events, lower the TTL, cost effectiveness, which is what we talked about with throttling it, scales the number of processes, and basically the important part is you have both your code and the infrastructure in one project. You have a command off the shelf to deploy it, which is just script. Because I'm a developer, I'm not a DevOps. I don't want to be spending time building scripts to deploy the code. No offense, some people like it, I don't. So when the Serverfull, you usually have it the other way around. You have a code in a project, and you kind of have to build a pipeline if you want a full CD setup, and you have to maintain that pipeline as well, which is serverless is just easier. I'm not saying it's one is better over the other. You can also have a deployment full CD pipeline if you're using serverless as well. I believe that's what C is doing. But I just run it from the command line and I deploy it, and it's cool. All right, talk less, build more. Let's see a real example. Those FTP drop sites were fairly simple, right? It's easy to understand what happens when stuff gets complicated. So you have your main data, then you have kind of integrated data, which is the data that gives you new features and the edge to build stuff in your product that the competition doesn't kind of have. And of course, analytics. Everybody wants analytics. You can call it AI, machine learning. It's basically a lot of data, and you take terabytes of those data and you come up with something valuable that says, this is a good deal on a car, or this is a good deal on vacation, or a house. So, and the last point is you always want more data, because the more data, the more stuff you can do with it and potential value. So, let's build a car search platform. I like cars. I like motorcycles more, but cars are kind of easy because everybody bought a car one time. You always went to those used car websites, so you kind of know what it's about. So, start simple. SFTP. Oh, actually, I did put SFTP. I updated that one. So, SFTP drop site for dealerships to give you the data. let's imagine they do give you the data and SFTP drops out. Now in reality it does not happen, but let's get the whole business complexity for it. So you're getting the data, drop to your S3, you want to normalize it, you want to push it to, that's actually an SNS icon and an SQS behind it. Bonus question, why would you use SNS and an SQS behind it?
Go with parallel workflows.
Exactly, fan out. Like you want to fan it out. You want to parallelize the work as much as you can. Let's say you're calculating the median or average value of something and getting the image for the car as well, or getting the specs from a specs website. So you can do that in parallel. And then you basically put the stuff in DynamoDB, which is, I like to use it as intermediate storage because it's fast and you can easily retrieve data from it and do whatever you want later with. All right, it's a search platform, it needs a search, right? So let's index. That little blue round thingy is not an official icon for the DynamoDB stream, but it kind of looks better than the official icon, so I used it. Are you guys familiar with a DynamoDB stream? Basically, imagine everything that gets put into a database, you get a message saying, this is what was put in the database. This is the difference, this is an update, what it is. It's basically a notification of what has changed in the database in a single message per record that was changed. Pretty cool feature. Hey, catch that.
That's where you tell the podcast
Kind of, yeah. You could put it out. I call it a notification, an update notification. It's easy. And then basically, whatever it's updated in DynamoDB, you have a lambda that reacts off of that stream and puts it in Elasticsearch. And as everybody knows, once you have an Elasticsearch, possibilities are endless. You can search on it, you can put aggregations, you can count it in those buckets, categories, whatever. I think almost every powerful search website platform runs either a version of Elasticsearch or Solver, unless they have a customized version of what's underneath the whole solution, which is basically a C index.
So now you have the same data in DynamoDB
Yes.
as well as Elasticsearch.
Yes.
So we have two.
You do have overhead. The data in the DynamoDB is going to be a lot cheaper, and you can clean it up whenever you want.
So which one is the source of the data the DynamoDB or?
So they should both be consistent? Should. Eventually. All right, so remember when I told you about the critical data path? This is it. The path between the data and when the user can actually see. This is the thing you want to keep as short as possible, as fast as possible, completely event-driven, and minimize pressure points and points of failure. And as you can see, this path has no servers on it, it's event-driven, so it's, in theory, instantaneous for the users, and it's going to scale. So as you get more users, like in a startup, let's say you have 10 clients, you get 30 more, right? You usually have to refactor some pieces of it in order to handle 2 times more client than you have right now. Here, they just drop more stuff when there's 3 more lambdas pop up. Even if you hit the 500 lambdas in parallel limit, just rename the lambda and create another 500. So it's a hack of it more than once. All right.
I didn't really understand, if you just go back one slide. I didn't understand the object, main data, DynamoDB, and DynamoDB stream. Is one of them a database, the other one is a stream?
DynamoDB is a database. And the DynamoDB streams is basically a feature of the database to give you identification about what changed.
Okay.
That's the best way I can abstract it.
I have a question, usually is, something experience on myself with, I'm not using streams.
Okay.
Instead of the lambda, I send it, I write to DynamoDB, and right after I send an SMS to a topic, which the other library I subscribe to. Is there like a way to difference?
No, this is, it couldn't fit in the picture if I added one stuff. You could add a queue and SNS, whatever you want, but the queue would be good. I would actually, like in reality, I would put a queue. That's a good observation.
So can you, the reason being when they use these databases for streaming data, that actually means you want to replace this new components, have like the streams data database, connecting those two streams.
Can you name one of the strong databases?
I think these guys covered in the session yesterday. We were talking about how they exist one database that was actually optimized for streaming data.
A database optimized for streaming data.
Yesterday you guys were covering about this one database that is optimized for streaming data that they introduced in the
Time stream?
Yeah. So can that be used instead here to replace the dynamics and the
So basically, streaming, Kafka,
So it can, so there's different use cases for different databases. So you have the time stream is good for storing. I think it really depends on the workload and how we scale the handle traffic. So I think Dynamo is less to maintain and will scale better. I can break it out by. This is kind of the simplified thing too. I can multiple partitions that parallelize my execution for. So Dynamo is a really good fit for that way, especially for in this model. Most of the searching probably is not happening in Dynamo; it's happening off the Elasticsearch. So I could put the extended Elasticsearch. I could put the time stream data in there. That might be, depending on the, it really depends on the type of data. So in that model, maybe the time stream database would be better than the Elasticsearch.
What you could do is, what could be a cool feature? Imagine if there was an SNS fan out and you have two queues and you put the general search data in search and you put the time series data in the time series database. Like I said, this is an example, this is not written in stone. Although I worked, I had to refactor the architecture pieces at least once a year. Something new comes up, like for instance the database, and you previously had it somewhere else, and now there's a way better database to handle the features that you have. Switch it. All right, so what do we need more? This is just the basic search, right? You can only see cars. Like when you're buying a car, you kind of want to have car proof, right? Which is a good example of external data. So anytime you get the information about a car, you want to get its car proof in parallel. Again, let's assume that the business is done and somehow they got us API integration to car proof. I'm not going to go into the business side. So you're getting the car proof. There's a fan out. You ping the external API, get the external data. Again, put it in a database. Dynamo, as an example, a stream triggers the indexer, ends up in Elasticsearch. It means now you have the ability to search for cars that only have car proof. If you just want to show car proof for a car, then you don't need to index the data. Again, just an example. So this is basically to show that even in reading external data, again, serverless is going to handle it. You don't need more hosts to constantly keep pinging the external host and getting the data. All right, let's make it more complex. We want more data. So there are dealerships that don't want to give us their data. So what do we do? Exactly. Problem. Scrape one. Whatever. I actually had a case where I had to, a big shipping company wouldn't allow us API integration because they thought we were a small startup, they didn't want to work with us, their API integration teams, onboarding pipeline was too busy or something like that. I don't know what the excuse was. So we build a Lambda that will scraping their website. You know, log in, use Anthem.js, download the spreadsheet, push the spreadsheet onto S3. So you're getting more data. Again, another example, serverless. Let's say you're running out of money. Turn off the scraper. Just put it one Lambda every hour, whatever data we get, we're getting. We got an investment, sure. 500 scrapers. Scrape everything we can get. Put more data in there. And like I said, get more data any week. Your product owners, product managers, sorry, I'm terrible at speaking, I'm not used to the mic, I'm very loud. Product owners, product managers, CEO, if you're a small startup, will always have more idea of what to do with the data. So any idea you have how to get more data, tell them. They'll tell you if you should do it or not. And like I said, following the internet is always a good way to get more data. So, what are you going to do now? You got a ton of data. You need to get to know your data, right? How do you get to know your data? Anybody using Elastic MapReduce or Hadoop or Yarn, whatever you want to call it? Okay, basically, imagine an infrastructure where you tell it the location of the data on S3 and tell it the key, how to join the data. Let's say this is a car search platform, right? It has VINs, right? So let's say you take VINs too specific. Let's take the car model, make, and year, and you aggregate all that data. You can basically come up with an average price for a Ford Mustang 2007 on your platform. And then with that data, whenever a new Ford Mustang comes in, you can say, hey, this is a good deal. This is 2,000 below average. Or this is a bad deal, it's 2,000 above average. But you need to get to know your data. And Elastic MapReduce is really good for that. It's basically MapReduce platform. So join the data on a key. In this case, we said make and model and the year of a car, and then do all sorts of interesting stuff on top of that. It may even be, there's something interesting about cars in a zip code, cheapest car in your zip code for a given year, or cheapest car you can drive an Uber with. I think there's a lot of people in Canada who love that feature. All right, like I said, experiment a lot. Okay, now you have a lot of data. You have a lot of people know about you. What do you need to build? That was a question. You already have that. If you didn't have a website, there wouldn't be money to build all of those. Close, API what?
Yeah.
API what?
You need some.
For external users to use and other companies. Yeah, API integrations, basically. You want to allow people to drop you data with a REST API call, or you want them to have access to your analytics, or whatever other use case that makes money for a startup. Like I said, it's a startup. The more value you potentially have, the more value the startup has. So this is basically as complex as we can get. A lot of times, people would build the perfect architecture and then spend months on building the architecture, and then they would realize they have 3 weeks to build it. And they would not build what they architected. They would just build whatever fits the needs. So my advice is architect fast, make it modular. So let's say you did the architecture of this, right? You realize you don't have time to build it. Build the critical data path. And then maybe later you'll realize your users don't care about carpet, or they do care about it, or the second piece, the analytics, you need data for that, so the critical path has to be running for months before you can build the second part. And next thing is serverless empowers infrastructure as a code, which is something you definitely want as a startup. Like as a startup, you don't want to end up in a place where, say, one of the founders leaves, and when the developers ask, okay, where's that queue, or like, where's this service running on? Well, the guy who was maintaining it left. We don't really know. That does not happen in serverless. Because you have it in the repo, its version, it's up to date. You just open it, you know how to deploy it, you know where it runs. Simple. There's a term I recently heard, perpetual beta. Is anybody aware of what it is? Go. Gmail. Yeah, true.
Keep things in beta forever so you can get feedback from it.
Exactly. Things are always going to change. I kind of dropped an Easter egg on you guys at the first slide regarding this. Does anybody remember something on the first slide that was off? No, don't cheat. Okay, I'll scroll back. Anybody see an Easter egg? Something that's not supposed to be here? Okay, I'll tell you. It's development infinity. Basically means the work is never done. Whatever you build, you're gonna want more features. You're gonna want to make it faster. You're gonna want to make it cheaper. The worst thing they make you do as an engineer, but sometimes you gotta make it cheaper. So that basically means perpetual beta. It means you're always in a beta stage. You're never in prod. You're never just maintaining what is. You're always building new stuff. Things are gonna break. It happens. But adapt, fix it, and go. Yeah, perpetual beta and development. So, what this has to do with startups? So, like I said, in startup, you usually have one or two guys, right? You want to have those guys getting servers, going to Costco, buying them, hosting on servers, and fixing servers. No, you don't. You want them building your startup, which is your own code, right? So, another thing, you have a client which uploads one file a day. You process that file and say you offer search and all of that. So your client made a mistake. Instead of one file, he put a folder. Let's say he's root directory on his 500 gigabyte hard drive. Yeah, that might break some stuff if you have one server running. If you have serverless, you'll pay a bill. If you design it correctly, you'll get an alarm. Nothing will break, but it still won't kill your app. And for example, Christmas time, you have a shopping app, right? You need more servers. Everybody needs more servers at Christmas time. Everybody is running an e-commerce website or an app, or let's say, dumb idea, buy my friend a gift. I don't want to deal with it, just buying something. You have an app for that. Imagine how many people are going to click that at Christmas time. You want to make sure it scales. You don't want to go around having your developers trying to figure that out 2 days before Christmas and then get stressed and quit. That's not a benefit. As I mentioned a couple of times, infrastructure less chaotic. In startups, infrastructure can get chaotic a lot. I've seen, I went into 2-year-old, 3-year-old startups where they would have processes running and nobody knew what they were doing. And sometimes people were just like, don't touch it. So if you have it in the code, in the serverless config, you kind of know what it does. You know what it's triggered on. You know the code is in the same place where your infrastructure is. Second thing, you have a single tenant system, right? You kind of want to build. Your client's paying a lot of money. He wants a custom version for himself, so you got to recreate the infrastructure. Imagine if it was being built for 2 years with 3 guys and then 1 guy left and you gotta recreate the whole thing. It's gonna be like, who created this queue and like, what triggers that? Again, you have it in the code. It's just a matter of picking a name for the new environment for the new client. Easy. Reduces the amount of throwaway code. Startups pivot a lot. You're going to be building stuff that you might want to throw away. If you're building it modular and serverless, the amount of throwaway code is going to be less and less. For example, somebody here mentioned they have something between a monolith and a serverless app. Like, where is that somewhere in between?
It's more towards monolith at this moment.
Okay.
Yeah. So, so the product that I'm currently working on is more of like analytics application, and it has a data pipeline that prepares the data.
And data pipeline is in a monolith.
It is monolith right now.
And how much of it are you going to throw away?
So, since we had to deliver this product,
Don't worry, be honest. It's not
yeah,
going
I'm
to go through a
honest
process.
about it. So I'm trying to tell the scenario. Actually, I had a question.
No, go ahead.
So, for building this pipeline, we had to do it like quickly to get to the proof of concept of this product and in production.
Exactly, like any
and
startup.
then move on to something like more scalable and stuff like that. So we built this pipeline, which is monolith pretty much, and it's built on workflow tool Java-based called talent job. So it just takes the data and processes it and aggregates and puts it into the target database. So it's pretty much a monolith, and if you have to really, like I said, if you have to build something better,
Build a version that scales and it's cost effective.
we
How
just
much
have
are
to
you?
throw 100% of this and
100% away, right? See. That's a very good example of what I was talking about. Because a lot of startups I work with, and a lot of startups that are our client right now are in a kind of single spot. Somebody created a monolith. It worked fine where they had 3 users a day and 5 clients giving them data, but as soon as they got 100,000 of clients giving the data and 50,000 users, it just blows up. And then the hard reality hits the founders when you tell them this has to be thrown away and rewritten 100%. Like, that's the bad news. Good news is you can reduce that amount by using serverless. And then the big important thing, you're a startup, right? You may have just $3,000 a month for your infrastructure. You may have $100 a month for your infrastructure. And you kind of need to keep it down. That's what I said. Serverless gives you that. You don't have the money, slow it down. It's going to cost you $500 a month. You got funding, just increase the number of parallel lambdas that are processing it. And you know how to do it because it's a one-line change in a config file that you can deploy with a single command. So, cost effectiveness. Yeah. Why is our infrastructure bigger than our payroll? I've actually heard that 2 times with 2 completely different startups. The bill was insane. And yeah, that's all. Any other questions?
We have pizza as well in the questions. I don't know if I want to start.
No,
with
go.
that.
Don't let the pizza get cold. Go grab the pizza.
It's not talking. We can have like it's party now. So let's begin eat and drink and talk. And I think this is perfect segue into how we plan it for the next year. Like his example of sharing his own architecture. Like I want you, if you're working for a startup or running anywhere or planning a company, to come up with a small talk, 10 minutes to 30 minutes. It doesn't have to be massive like this and share. We want ideas to keep flowing next year. So thank you for switching.
No worries. There was also a person here a few times before this one. They talked about in the company, they have like a monolith, they don't know how to switch to serverless. That's also a great idea because we could do case studies, like we can just, somebody can show what they're struggling with and everybody's gonna pitch in with an idea because there's this, I'm just gonna say this and you can go grab pizza. There's this urban legend, my dad works at a power plant and it's one of those old coal power plants. So there's turbines and there's steam and one of the turbines just wouldn't start and nobody knew how to start it. And they spent 3 weeks, they couldn't start it. So they invited this expert. The expert came by, looked at it, looked at the pressure gauges, took a big hammer, hit it 10 times, the turbine started. And then he sent them a bill for $10,000. And the CEO of the power plant says, what, $10,000 for hitting it with a hammer? I was like, no, I want that itemized. And he said, okay. So he sent it item first, hitting it with a hammer, $100. Knowing when, where, and how hard to hit it with the hammer, $9,900. So, like I said, we can bring in a couple of problems you're dealing with. We can all discuss it. Sometimes somebody might have experience with that. They'll solve you a headache you would have for a month.
Yeah, and even add to that, it doesn't have to be stuff you have problems with. If you built something and want to share it off, you want
Yeah.
feedback and how to make it better and stuff, like this is a great way to go and share that as well.
And also it's cloud agnostic, so it doesn't have to be AWS only, like any cloud. So I think we already have volunteer for Google.
Yeah, like at my work, we do Google Cloud, and we don't use serverless, we use Kubernetes. So I'm kind of like the devil's advocate right here. And
No,
thinking
I would love to hear about that. 'Cause,
yeah, so if I can prepare something, I wouldn't mind like showing why we use Kubernetes. And once I get a chance to play with this, I'll have my opinions like when you use each.
Great, that's how I got to do this. I volunteer.
That's perfect. So guys, feel free to start eating and talking. Who else wants the mic? Or pizza? We have all kinds of pizzas for vegetarians and.
I suggest everybody goes grab pizza before it runs cold, and then
it's
we'll be
only
here.
15 minutes old, so. And then the drinks are behind. There's Diet Coke, and ginger ale. You have vegetarian pizza if you don't think so.
Sure,